Today we're going to talk about polynomial functions of higher degrees. So a polynomial function is smooth and continuous. A function is continuous if it has no gaps, no breaks, no holes, or asymptotes. Basically, it's continuous if you can draw the entire thing without picking up your pencil. It is smooth if it has no sharp edges or cusps. So let's look at a couple of examples here. This function is continuous and it's smooth, okay? You can draw the entire thing without picking up your pencil. There are no sharp edges, there's no cusps. All right, this one over here is not continuous. First of all, it's got a vertical asymptote right here where it just jumps from infinity down to negative infinity. It's got another one right here where it jumps from negative infinity to positive infinity. So anytime you have an asymptote, it's not continuous. It's got a hole in it, so it's definitely not continuous there. This part is smooth, this part is smooth. This part is not smooth because it's got a sharp edge, which is called a cusp. In this case, where it comes up like that. So it's not smooth or continuous. The degree of a polynomial is equal to the largest power of f of x. So the degree of the polynomial x to the fifth minus 4x to the third plus x squared plus 7x minus 2 is 5 because that's the biggest power. And again, I mentioned this last time, it doesn't matter what order these are in. I can switch this around. A lot of people make a mistake on this question because they jump to the front. So if I put the x to the fifth over here, they would look at this part and they go, oh, it's degree 3. No, it's the biggest power no matter where it is in order in the equation. Okay, parent function for cubic functions, that would just be the function x cubed. All right, the domain. We'll go through the domain here. The domain is the set of all real numbers. Okay, I can take any number I want along the x-axis and I can cube it. No problem there. The range. The range is also all real numbers. It's all the y's because it goes to negative infinity down here. It comes up to 0, and then it goes up to positive infinity up there. So the domain and the range are both all real numbers. It has an intercept at 0, 0. That's both the x and the y intercept. It is increasing on the interval negative infinity to positive infinity. This thing is always increasing. It is never decreasing. It is an odd function. It's odd because I can take this equation and rotate it 180 degrees and I get exactly the same equation. So it's symmetric to the origin. All right, so there we go. So graph the equations. So negative x cubed, well, it's going to look just like positive x cubed, except it's going to be backwards. Okay, so, you know, I can just plot a few points. If I cube 0, I get 0. If I cube 1, I get 1, but it's negative 1. If I cube 2, it's going to be 8, but that's going to be negative 8 here. If I cube negative 1, that's going to be negative 1, but then it becomes negative again, so it's positive. And again, here, and so this equation looks like that. Okay, that is also an odd function. If I rotate it around the origin, I get the same equation. The domain is all real numbers. The range is all real numbers. Okay, what about this one? X cubed plus 1. Well, if you remember your transformations, all this does right here is bump up x cubed 1 place. So that means that instead of going through the origin here, it's going to go through 1. And instead of going through 0.11, it's going to go through 1, 2. 2, 9. It's going to go there. It's going to go there. So my graph looks like this. Now, this function is neither odd nor even, because if I rotate this thing 180 degrees, I do not get the same function. This point ends up down here. So it's not odd, and it's certainly not even because it doesn't reflect over the y-axis. Okay, this one here, the transformation is inside the function, so that moves it, if you subtract one, it moves it 1 to the right. So this function would look just like the x cubed, except it would be over here. So it would look like this. It's neither odd nor even either. So just a refresher for transformations. If I take a function and I graph the parent function, if I add a number onto that function, it just moves that function up. If I subtract a number, it moves it down. If I add a number inside the function, it moves it to the left. If I add it out, or if I subtract it inside the function, it moves it to the right. And if I throw a negative on the front, it just flips it upside down. Okay, odd degree functions. The degree is an odd number. So the leading coefficient is positive. A function is going to look something like this. If it's an odd function, it's going to look something like that. Okay, that would be a cubic right there. Now, it could be a fifth power. It could look something like this. If the leading coefficient is negative, it'll look like this, or it could possibly look like this. Okay. If it's an even degree, so this would be an x squared, x to the fourth, x to the sixth. Leading coefficient's positive. It will look something like this. It could look something like this. All right, if the leading coefficient's negative, it might look like that. Or it could look like something like this. Okay, use the leading coefficient test to describe the right and left hand behavior of the graph. So with right hand and left hand behavior, we're talking about what happens on the ends of this thing in behavior. Okay, so this thing, negative x cubed plus 4x. It's going to look like a cubic. It's going to look something. It's going to be upside down. It's going to look something like that. Okay. Now I could graph this thing and find out exactly what it looks like. I probably would not choose to graph this by plotting points. So let's just graph it using a graphing calculator here. So we'll go ahead and plug in negative x to the third plus 4x. And we'll go ahead and graph it. And sure enough, it does look very much like this. So it kind of looks like this. Now, when you're talking right and left-hand behavior, all you're trying to determine is what does the ends of this thing look like so you get an idea of shape. So, for example, if you had an x squared, that's a parabola. It's going to look like this. The right-hand behavior, in your case, is going to be here, okay? It's going to go to infinity. On the left-hand behavior, it's also going to go to infinity. If it was negative x squared, it would look like this, okay? An x cubed is going to look like this. A negative x cubed is going to look like this. An x to the fourth is going to look like this. A negative x to the fourth is going to look like this on the ends. Okay, we don't know what happens in the middle. All kinds of stuff can happen in the middle, but that's what happens on the ends. Use the leading coefficient test to describe the right-hand and left-hand behavior of the graph. So x to the fourth. So this is positive. This function is going to go up here, and it's going to go up here. Now, some other things that we know, since it's degree 4, it can have 3 turns in it, up to 3 turns. So it could look like this, or it could look like this, 1, 2, 3 turns. All right, so if I look in my graphing calculator, I can confirm this. I go y equals, clear the equation, x to the fourth minus 5x squared plus 4. Go ahead and graph it. And it looks very much like this. It'll There we go. So it'll look like this one. And x to the fifth minus x. Okay, what's that going to look like? It's going to look like this. Okay, so it's going to go up to infinity here. It's going to go down to negative infinity down here. All right, I just kind of have to figure out what it's going to look like in the middle. So we can graph that, x to the fifth minus x. All right, and that's going to be a very steep equation. It'll look pretty much like that. Which my end behavior, I've got a pretty good idea of what that's going to look like right there. Okay, zeros. Zeros are super important to be able to find. Okay, zeros are where it crosses the x-axis. So this one has 3 zeros, 1, 2, 3. This one has 4 zeros, 1, 2, 3, 4. Okay, you got to be able to find those. So if a polynomial function is of degree n, the function f has at most n real zeros. So if it's an x squared and you find 2 zeros, that's it. There aren't any more. If it's an x to the fourth, if you find 4, you know there aren't any more. Now, there may not be 4. There may only be 2, or there may be 1, or there may be none. The graph of f also has at most n minus 1 turns. So if it's degree n, then it will have n minus 1. It can have up to n minus 1 turns. Okay, so what does this mean? So if you think about on a graph, let's say I have an x to the fourth. It could have 0 zeros. It could look like this. Be a real simple x to the fourth. Like a real simple one would be x to the fourth plus 2. It's going to look something like that. It's not going to have any zeros. It could have 1 0 if it looked like this. Got 1 0 right there. And it could have 2 zeros if it looked like this. Okay. Could it have 3 zeros? Let's get a new graph here. Well, let's see. The graph could look like this. Could come down, Go back up. It looked like that, an x to the fourth. So it'd have 3 zeros. One here, and one here. And it could have 4 zeros if it looked like this. 1, 2, 3, 4. It can't have 5. Okay, why can't it have 5? Well, I've got 4 here. If it's a degree 4, it can have at most 3 turns. So I have 1 turn, 2 turns, 3 turns. Now I can't turn to come back to cross that x-axis again. Same thing over here. I can't cross it on this end either. So that's why it's maxed out. Okay, all these things are some kind of x to the fourth, degree 4 equation. Okay, important things to know when you're analyzing a graph. Okay, so if it's degree n, it has at most n real zeros, and it has at most n minus 1 turns. When f is a polynomial function and a is a real number, the following statements are equivalent. X equals a is a 0 of the function. X equals a is a solution of the polynomial equation f of x equals 0. X minus a is a factor of the polynomial. A0 is an x-intercept. All those things mean exactly the same thing. They're just different ways of saying it. So find all the real zeros of f of x equals x cubed minus x squared minus 2x. Okay, so you're going to want to be good at factor. So let's take a look at this. We'll rewrite the equation here. Now all these terms have an x, so I'm going to go ahead and factor out an x. That leaves me with x squared minus an x minus 2. Now this is factorable as well, so let's factor that. So I got x squared here. I'm going to put an x here and here. I've got factors of 2 are 2 and 1. That's my only choices. I need to make a negative 1, so I'm going to have a negative 2 and a plus 1. And then you need to double check. Positive times a negative is a negative. So we've factored this thing. Now, we have zeros when this equation is equal to 0. So if I think about it, I have 3 numbers, 1 number, 2 numbers, 3 numbers. They multiply together to be 0. That means one of those numbers at least has to be 0. So because there's no other numbers, you can't take 2 and 4 and multiply it together and get 0. It has to have a 0 as one of those numbers. So if this one's 0, then that means x is 0. If this one is 0, that means x is negative 1. And if this one's 0, that means x is positive 2. There's my zeros. 0, negative 1, and 2. You could write them as 0, 0, negative 1, 0, and 2, 0 if you like. Here are my factors. Here are my zeros. These, I guess we'd call these the x-intercepts. Okay, so those are all the same thing. This is what I'd be looking for an answer, though. Notice it's a degree 3. It has 3 zeros. I know I have them all. All right, find all the real zeros and relative extrema of f of x equals negative 2x to the fourth plus 2x squared. Okay, so both of these things have a 2. They both have an x squared. And I think I'd like to factor out a negative as well. So I'm going to take out a negative 2x squared. That's going to leave me with x squared here, minus, because I took out a minus, and then 1. Now I can factor this further. Negative 2x squared. If I factor this, that's a difference of 2 perfect squares. You should recognize that from last year. So this is going to be x minus 1, x plus 1. Remember, a perfect square is a number. If you square root it, you get a whole number, right? So if I square root this, I get x. I square root this, I get 1. Okay, now if I want to set this equal to 0, I can find my zeros. Okay, if this number is 0, then that means x is 0. If this number is 0, then x is 1. And if this number is 0, x is negative 1. So there's my zeros. Okay. Now, if I wanted to, let's see, I know that this thing, an x to the 4th, would look something like this. Okay, it would have 3 extrema, it would have 2 relative maxes and a relative min. So I guess at this point I would find that on my graphing calculator. I'd go in and I'd put in the equation negative 2x to the 4th plus 2x squared, and I'd graph that thing. Okay, so if I graph it, this thing looks kind of like this. Okay, so it's pretty much symmetric right here. All right, so how do I find the extrema? Well, I can go to calculate. So you push the blue second key, and then above the trace there's calculate. And then you can go to minimum, there's number 3. And what it will do is it will put a little X somewhere on the graph. Now mine just happened to put it right there, which it looks to be right on the minimum. So it asks me a question that says left bound. So what I want to do is I want to move this just a little bit to the left of that point using my arrow keys. So I moved it to like right over here, and I hit enter, and then it asks me right bound. And so I want to move that little X back to using the arrows. I want to move it to the right so that I know it's on the right side of that. Hit enter again. And then it'll say guess, and I hit enter. And it says, okay, it gives me 7.6837 e to the negative 7 and 1.181 e to the negative 12. All right, what does that gibberish mean? That's a rounding error. Okay, what that really, those are tiny, tiny numbers. That's scientific notation. And what that really means is it's 0, 0. So there's a relative minimum at 0, 0. Okay, and then if I want to find the maximums, I would probably zoom in on this thing a little bit because it's really hard to see on this graph. So I would just change my graph a little bit so that, okay, there we go. And I think I'll even change the Y's. So now what I need to do is I have to start over with calculate. So I go second, calculate again, and then I use maximum. So that's going to be 4. And it's going to ask me the left bound again. So what I need to do is I need to put this back here. I need to move it way over here so it's on the left side of this peak right here. All right, so I'll arrow it way over there. Anywhere on the left side, hit enter. Then it asks me right bound. So now I'm going to move it over to right here somewhere, so I get both sides of this thing, hit enter. And basically what it's doing is it's marking this thing off here, and then it's finding the highest point in between those two. So it says guess, and I hit enter, and it says this thing has a relative maximum at negative 0.7071.5. And then the other one, since this thing's going to be symmetric, is going to be You can double check this if you want, but you got to start over. It's going to be there. So I've got my relative mins and my relative maxes. Okay. Repeated zeros. Okay, this is super important. For a polynomial function, a factor of x minus a to the k, where k is greater than 0, yields a repeated zero of multiplicity k. All right, so what does that mean? Let's say that I took the equation x squared plus 2x plus 1, and I factored it. So I get an x and an x. My factors are 1 or 1 and 1. Okay, I need to make 2x in the middle, so it's going to be plus 1 and plus 1. All right, x plus 1 times x plus 1 is x plus 1 squared. Okay, that means that this thing has a repeated 0. So what makes this 0? Negative 1. What makes that 0? Negative 1. This has it has two zeros, but they're the same. Okay, so what we say is that this has a 0 of a negative 1 with a multiplicity of 2. Now, it's important that you understand what happens with multiplicity. Okay, because if k is odd, if the power is odd, so this one's even, but let's say that was a 3, then this thing would have a 0 at negative 1, and it would cross the x-axis at negative 1. If it's even, if k is even like it is here, it just touches the x-axis at negative 1. So what does that mean? So if I had this versus I had this. Okay, both of these things are going to touch the x-axis at negative 1, but this one is going to cross the x-axis at negative 1. So it's a cubic. It's going to look something like this. Okay. This one is going to touch at negative 1. So what this one's going to do is this one's going to come down and it's going to touch the line and go back up. Okay? So that's why you want to look at multiplicity. Multiplicity will tell you whether you cross the graph or touch the graph. And what we're going to do later is we're going to analyze graphs where I'm going to give you a complicated graph, and you're going to be able to draw the graph without hardly putting any points on there. You're just going to know a bunch of stuff about that graph by looking at it. Okay, analyzing a graph of polynomial function. So find all the real zeros of f of x is x to the 5th minus 3x cubed minus x squared minus 4x minus 1. Okay, I'm going to pause this for just a second. Sorry about that little break, but I had to get a drink of water. Throat was really dry. Okay, so how are we going to do this one? Well, we don't know how to factor this yet. So what we got to do is we got to use the 0 feature on your graphing calculator. Okay, so on the TI-84, we're going to go ahead and push y equals, and we're going to plug this equation in. So it's going to be x to the 5th. Make sure you push the down arrow out of that, so otherwise you put everything up in the power and you get it wrong. Minus 3x to the 3rd. Down arrow again. Okay, minus x squared minus 4x minus 1. And then we'll set our window. I usually use the standard window negative 10, 10, 1, negative 10, 10, 1. So that's your window key, which is right next to the y equals key. And then we hit graph. Okay, and I get a graph that looks something like this. It looks like it crosses at 2. It looks like it crosses somewhere between or a -2. Looks like it crosses somewhere between -1 and 0. It looks like it crosses just past 2 here. And I know it's an x to the 5th, so it's going to go like this. So it's going to look something like this. It's got this weird little wobble right here. Oh, that's terrible. Here, let's just redo that. It's going to go way down here, and it's going to come up. It's going to look like that. Okay. Now, unfortunately, these things don't look like they land exactly on nice numbers. So how do I find that? Okay. So you can push second calculate again. And number 2 says 0. So you push 2. And what it did was it put this little x right about here for me. And it's asking me left bound. So what I need to do is I need to use the left arrow key and move this over to about here. Because I want to find this 0 first. And I want to be on the left side of that 0. So I'll arrow over there. I hit enter. Same process as last time. Now it's asking me right bound. So now I want to move the x over here somewhere. So I move it to the right. And I hit enter again. It says guess. And it tells me -1.860. Okay, so I've got that. It looked like it landed right on 2, but it didn't. So I've got 1 point here is -1.860. That's this one. And then I do it again. Second, calculate, 0. I'm going to calculate the middle one now, so I'm going to move it to the left of that right about there. Enter. Then I'm going to do the right bound, so I'm going to move it down to about here somewhere. Hit enter again. And then it's going to guess. And it tells me -0.2540. Now, sometimes when you use 0, you get kind of gibberish like we did the one time, where it gives you some kind of scientific notation. Okay, you just got to know that's 0. Now I'm going to do it one more time. Second, calculate, 0. This time I'm going to move my x like right over here somewhere. As long as it's to the left of that 0, hit enter. I move it to the right, hit enter. So I moved it up here somewhere. And then guess. And it says 2.11. 1150. That's that one right there. And so that's how you use the graphing the TI-84 to find your zeros. Okay? So I don't know if you can see, but here's your calculate button. You got to push the blue button right there. Okay? Calculate, and 0 is option number 2. Now, also, you can see there minimum is option number 3 and maximum is option number 4. I would be able to use those. All right, finding a polynomial function with given zeros. So now they're telling you, hey, this polynomial has 3 zeros, and one of them is -1/2, and one of them is 3, and the third one is 3. Okay, what does that mean? Well, that means simply this, that f of x is equal to x plus 1/2, x minus 3, x minus 3. So I change these, the first thing I do is I change these into factors. Now you'll notice both of these were positive, both of these are negative, this one was negative, it's positive. It's always the opposite sign. Now, technically that's the answer. That's not going to be accepted by me though, so you need to be able to multiply this out. So you're going to FOIL, I would FOIL this first because that'd be easier. That'd be x squared first. X times x is x squared. Outside is -3x, inside is -3x, that makes -6x. Last would be +9. So That's that step. Now I would probably, you know, some of you like to use the box method. I'm okay with that. It's just a lot of extra writing, I think, for myself. You know, so you got x squared minus 6x plus 9, and you've got x plus 1/2, and then you just, x squared times x is x cubed. This would be minus 6x squared plus 9x. This would be 1/2 x squared. This would be negative 3x, and this would be 4.5. Okay, you can combine your like terms now. So f of x, there's going to be x cubed. Combine my x's, so that's going to be negative 5.5. I don't want to write that as 5.5 though, so that's going to be 10 11/2. This is going to be minus 11/2 x squared. And then I combine these two, that's going to be 6x and plus 4.5, which I don't normally use decimals, but in this case I will because it's a nice decimal. Okay, the higher you go in math, the more you use fractions, the less you use decimals. Just letting you know that. All right, so there's my answer. There's the polynomial. It has those zeros. Now there's more. There's actually an infinite number of polynomials, because if I took this whole thing and I multiplied it all by 2, I'd have the same zeros. If I multiplied it by -1, I'd have all the same zeros. The graph would just look different. Okay, sketch the graph of 3x to the 4th minus 4x cubed. Now there's a couple things we can do. We don't have to jump right to a calculator, but I know this. I know this thing is going to look either like this, because it's next to the 4th and it's positive, or it's going to look like this. Okay? Now, I can do some things. I can find the zeros. So if we take the equation, see, I could factor an x to the 3rd out of this thing. That would leave me with 3x minus 4. Okay, and I can find the zeros by setting that equal to 0. This tells me that x is 0. And it has a multiplicity of 3. This one, I would add 4 and divide by 3, so it's got another 0 at 4/3 with a multiplicity of 1. Now I can go ahead and put that here. And I can put 4/3 is 1 1/3. That's going to be right about there. Okay. I know this thing's an x to the 4th. It's going to look like this. I know it crosses the x-axis here and here because the multiplicities are both odd. Okay. Now I don't know exactly what this thing looks like, but I know it's going to look something like this. Now it's possible this thing could have 3 turns. It might have another wobble in it up here, or a little wobble in it up here. It's not going to cross the x-axis again, though. So I can get out my handy-dandy TI-84 plus C Silver Edition graphing calculator, double check my work here. So I got a 3x to the 4th minus 4x to the 3rd. And I can hit graph. And it's pretty tiny in here, so I'm going to go ahead and stretch my window out on the x-axis a little bit. Make it my x-min -4 and my x-max 4, so I can kind of zoom in there a little bit. Okay, so this thing does look a little different. It does have a little wobble in it. So this side is actually correct, but I just drew it poorly. This side is correct. This part down here is a little different. So this goes up like this. And this kind of does this little turn thing, like that. So I've got 1, 2, 3 turns in that, which is the most I can have. And so I know that my graph is, I can't really do much more with that. Now, my original guess was not exactly correct, but it was pretty close. Okay, so let's sketch the graph of 2x cubed minus 6x squared minus 20x. So I'm going to take the equation and I can factor out a 2x on this thing. That would leave me with x squared minus 3x minus 10. I'm pretty sure I can factor that, so let's try to do that. Factors of x squared are x and x. Factors of 10 that make 3. So my choices are 1 and 10, which I can't make 3 out of 1 and 10. I can make 11 or I can make 9. Or 2 and 5. Okay, that looks like my winner because, let's see, negative 5 plus 2 would be negative 3. So now this tells me I've got a 0 at 0, I've got a 0 at negative 2, and I've got another one at positive 5. They're all odd multiplicities because they're all the first power, so it's going to cross at all three of those places. So let's go ahead and put them on here. It's going to cross at negative 2, at 0, and at 5. Okay. It's an x cubed, so it's going to look like this on the ends. Okay, so this is going to go to infinity. This is going to go to negative infinity. I know it's going to cross at all three of these, so it's going to do something like this. Now, the only thing I don't know to graph this is I don't know, does this go way up here and then back down, or does this go way down here and come back up? I don't know. But what I could do is I could just graph a point, just figure out, okay, what happens at negative 1? Well, if I plug in negative 1 here, if I find f of negative 1, that would be what? That'd be negative 2 minus 6 plus 20. So that'd be, what, 12? This does go kind of a ways up here. Okay, so that's going to go clear up to 12. It's going to go way, whoops. This thing is going to be way steeper. This thing is going to go way up here. Okay. And then I might figure out, I might find f of 3. All right, just pick something in the middle. Now, that doesn't mean that it's going to be symmetric here. It's giving me an idea of where this thing's going. So if I found f of 3, see that 3 cubed, whoa, that'd be 27 times 2 would be 54. And let's see, 3 squared would be 9 minus times negative 6 would be negative 54. And then, so those cancel out. And then I've got 3 times negative 20 would be negative 60. So this thing would just drop off my chart. And then it would come back up. It would go like that. Okay. So, I would always, if you're having to analyze a graph to graph it, I would always double check it by graphing it on my graphing calculator when I was done. Now, if you just put the graph down, it's going to be wrong because you don't have any of the work that goes with it, like finding the zeros or finding the x-intercept or the y-intercept, that kind of stuff. We'll get into more of that later. Okay, the intermediate value theorem. Let a and b be real numbers such that a is less than b. If f is a polynomial function such that f of a is not equal to f of b, then in the interval ab, f takes on every value between f of a and f of b. Whoa, brain exploded. What does that mean? All right, one of the skills that you need to have if you're going to take any higher level math is you need to be able to read a math textbook. Okay? This is straight out of the textbook. So you read that and your brain explodes. What in the world? I don't understand it. You need to go back and figure out what that means. Okay? So one of the ways you can do that is to sketch a picture. So I'm going to sketch a picture. So what does this say? I've got two numbers. A is less than B. Okay, so here's A, and here's B. B is bigger than A. All right, if f is a polynomial such that f of A is not equal to f of B, all right, so it doesn't tell me what f of A is going to be or what f of B is going to be. It just says they're not equal. So I'm going to put f of A right here, and I'm going to put f of B, say, right there. Okay, they're not equal. I could have put this one higher and that one low. It doesn't matter. Could have put them close together, further apart. All right. So what this now says is, since f of A is not equal to f of B, then the interval A to B. So what that means is, from here to here, f takes on every value between f of A and f of B. That means that f is going to be, it doesn't matter what it is. I don't care what this does in between here to get from there to there, but it's going to take on every value between f of A and f of B. That's what the intermediate value theorem says. So if this was like 1 and this was like 5, this function would have every value between here and here, would take on every value between 1 and 5. So if you said, well, is it going to be 4.732? Yep, it sure is. It's going to be right about there. Okay? Somewhere in between there, it's got to be the same thing. Now, the only time that doesn't work is when f of A and f of B are the same number, and then you don't have any idea what happens. It's just it might be a constant function. It'd be something like this. Here's f of A and here's f of B, and they're the same, and I don't know, does it go straight here? Does it do this? Does it do this? I don't know how it gets there. So that's why that doesn't really make any sense. Okay. Ooh, what does this mean? This means homework. Ooh, look at this. A polynomial function in real life right there. Okay? So anytime you ride a roller coaster, you're riding a polynomial function, and here is your homework. I know it's a little bit hard to read, but I think it's readable. If it's not, let me know, and we'll make some other kind of arrangements. But that's your assignment. Here's the problems you're going to do, and I will see you next class.